So this is section 4.4 on trig functions of any angle. So now when we look at the trig functions, we're not just going to be looking at them from values on the unit circle. So the unit circle has a radius of 1. What if we have a point that's not on the unit circle, so that doesn't fall on a circle with a radius of 1? We can still find all 6 of the trig functions. And the way that we do that is by calculating what the radius is of the circle that the point is on. So what I mean by that is, let's take, for example, this point here, x comma y. So what if this point x comma y was equal to about maybe -3, 6? So -3, 6 is not on our unit circle, but we can still find these values by solving for what is the radius of this invisible circle that it does fall on. The formula for that is right here. R equals the square root of x squared plus y squared. So this formula comes from the Pythagorean theorem. And no, it is not the same thing as canceling out the squares with the square roots and it being x plus y. You actually do have to plug it into the formula. You can't cancel those out. It has to be this formula that you plug into. So our definitions of sine, cosine look a little bit different. So instead of sine being equal to just y, like it was on the unit circle, it is now equal to y over r. So we're actually not changing this definition. Just before, when our radius was 1, we didn't have to include that because y over 1 is just y. So that's why on the unit circle, our radius is 1, so sine is just equal to y. But if we have a point not on the unit circle, sine is equal to the y value over whatever you solve r to be. Cosine is equal to x over r for the same reason, and then tangent is still equal to y over x. The reciprocal functions follow the same pattern they always have. Cosecant is the flip of sine, so r over y. Secant is the flip of cosine, r over x, and cotangent is the flip of tangent, x over y. So an example of a problem you might see might look like this. Let 3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. So the first thing we want to do is draw out this point to get a visual idea of what this is asking us. So theta is talking about the angle that is made when we connect our point to the origin. So right here would be our angle theta. This is our point, and we need to solve for the radius. So the radius is equal to the square root of x squared plus y squared. So this is my point, x comma y. So this would mean when we plug this in, we get 3 squared plus 4 squared, which is the square root of 9, plus 16, which is the square root of 25, and 25 is a perfect square, so we get r equals 5. So to find sine, cosine, and tangent of theta, so notice I put sine theta, cosine theta, tan theta. We use the rules that were on this last page. So sine is equal to y over r, 4 over 5. Cosine is equal to x over r, 3 over 5. And tangent is equal to y over x, 4 over 3. So that is the basis of how you can solve for sine, cosine, tangent, and the other reciprocal functions using a point. So here I have some extra examples for you to try. This first one I'm going to show for you, and then you can try this one, and I will put up the answers for you. So for the first one, if we were to graph that, -2, 1, there is my point, -2, 1. So my angle theta is right there. And that's not a necessary step to do, but it does help you to visualize it. Next, we want to solve for r, so -2 squared plus 1 squared. We're going to square root that. So this equals the square root of 4 plus 1, which equals the square root of 5. So here, the square root of 5, that is not a perfect square, so we leave it as a square root. So when we go to plug into the formula, sine theta equals y, so that is my y value, 1, over the square root of 5, which is r. we have to rationalize the denominator. So we need to multiply by that root, because in simplest form, we do not have roots in the denominator. So here we get the square root of 5 over 5 as our sine theta. For cosine theta, we do the same thing. So that is x over y. Once again, we have to multiply by root 5 over root 5. And here we get -2 root 5 over 5. And for the tangent of theta, that is equal to y over x, so 1 over -2, and we can leave that alone. And I'm going to put up the answers to these two if you want to pause the video, give them a try, and then check your answers. And so here's the work for B and C. For B, we had a perfect square for R, so sine is -3 over 5, cosine is 4 over 5, tangent is -3 over 4. And then for C, we got the square root of 17 here. So we get -4 over the square root of 17. When you rationalize the denominator, that's -4, square root of 17 over 17. Cosine is -1 over the square root of 17, so that becomes negative square root of 17 over 17. And then tangent is -4 over -1, which just becomes +4. And that is how you find sine, cosine, and tangent of any point.